going back in the model, let's apply these loads now. So if we go back, we want to go to area loads. What we're doing is we're applying that PSF magnitude area load. Now instead of having to find the calculated or distributed width of each of these members, or the tributary width of each of these members, and then applying distributed loads directly, you can use area loads to do that automatically. So the type is where you would indicate whether or not this is a one-way or two-way load. And what we mean by that is how many ways or how many directions does the load is the load able to travel. So one-way load is probably what you're typically seeing, where if the load is in here, it's either going to go to this beam or this beam. Whereas a two-way load, it can distribute to all four sides of the panel that it's sitting on. So we'll use one-way loads, and I'll actually put a two-way load on here just in case to show you what we're talking about. But we'll apply the one-way loads first. Let's type in the corner nodes. You can see that those four nodes are selected. And then our pressure magnitude is in KSF, so we want to do 0.02. So that's minus in the down Y direction, the global Y axis, and then minus global Y axis. And this is 20 pounds per square foot. Now the column beam direction is something that you need to identify as the direction that the columns, because this can also be used in the lateral sense, or the direction of the beams that are being distributed on it. So again, what we mean by that is the direction is, what we shown here is 4, 11. So this beam runs from 4 to 11. So we want the beams that are running in this direction to be distributed to. If we had our column beam direction be 4, 5, it would only distribute to these two red beam lines here. But we'll keep this the same. And then when you go to the load group, this has nothing to do with the actual load cases of the load. This is where you'd have to there's another portion of the workflow that that you'll see in the demo that you want to go through to actually assign the load cases to those load groups. The load group portion is just an arbitrary name that you can use to keep track of the loads, especially when they start to pile up and you have multiple. So we can type in here, since it's just the roof dead load, we'll type in roof dead load. We'll apply this. You can see that now we have a global Y pressure or load in this direction. Alright, so let's apply the dead load to the other side of the roof now. Back to area loads, one-way area load, and then again typing in the nodes. What you'll notice is when you're typing in an area load, the first two nodes that you type in will be automatically put in the column beam direction. So it's a good habit to get into, to start with one of the nodes and then follow the direction, or have the next node be in the direction that you want the distributed members to be on. So 11, 3, 2, 9. Again, it's minus 0.02. And there's that column beam direction I was telling you about. And then we want to match the load group. We don't have to type this in, but I'm just going to for clarity. We can select it here. Again, hit apply. Now we have loaded up our roof with its dead load. And you're probably thinking, well, we already have the dead load of the members here. Why do we need to add more load to the roof? That's because there's things that we can't accommodate for in structural analysis in this type of software, such as roof cladding, insulation, anything that's being put on top of the actual structure that the structure also has to support. So what we want to do now, and we want to get a very good habit of doing this, is turning on the equivalent distributed loads. So you can see that, and again, you won't find this really in any other software. This is something that we pride ourselves on, is having this feature. This is what the solver will actually run with. I'm going to turn the scale down a bit. So as we mentioned, the one-way loading action means that these members in the column beam direction that we identified are the only ones being loaded. So any of the load that's inside of between these two members is going to either go to one or the other. And same with it in here, it's going to go to one or the other. That's why you don't see any loads on the actual ridge here or on the actual outside members. And you'll notice that you can check the correctness here by by hand, you can calculate the tributary width of these members and then multiply that by 20. And we know that these are spaced at 10 feet, so we know that the distribution is correct because it's 10 feet of tributary width multiplied by 20 PSF gives us the 0.2 kip per feet. And we know that on the end it's also correct because it has half the tributary width, only has 5 feet of this width, and that's multiplied by 20, and that's where we're getting the 0.1 kip per feet. So again, it's always good to have this being shown at some point or another to make sure that the loads are being distributed correctly. Now I also want to mention that with slope structures like this, you want to make sure that the y-intercept or y value of each of these nodes along the length here is the exact same. So we see here that the y position is 19.225 for this ridge node, and down here the y position is 18 feet. We want that to be the exact same for each of these nodes. Now if this was 19.2253, like if you were, you did something where it wasn't the same, you can see that now that it's not recognizing that this member is in the same direction as these other members because it's just a tiny bit off the same plane. So we need to put that back to this, hit apply. Now we're back to normal. So now we kind of get the workflow. I'm going to apply the roof loads in the same way, and I'm just going to add them as the roof live load group, and we'll come back after that's completed. Okay, so we're back now. We applied the live load, and we can see that if we go to the visibility settings and we go to loads, we can toggle off really easily any of the loads that we have, and we can see that the load group that I used for the live load is just roof live load. So we can tell, hey, this is the roof dead load. We'll hide that, put on the roof live load. But because they're the same magnitude, they're going to look the exact same.